Hello everyone, myself Gautami K from Sri Venkateshwara College of Engineering. Today let's see the topic process models in software engineering. Let's see the introduction to process models in software engineering. Process models provide a structured approach to software development, guiding terms through the various phases of the project lifecycle. Understanding these models is crucial for effective project management and high quality software. Waterfalls model requirements define the software features, functionality, and user needs. Design develop the technical architecture and solution design. Implementation write the code and build the software components. The waterfalls model follows a sequential linear approach to the development, with each phase completed before moving to the next phase. Next, iterative and incremental models. Iterative software is developed in small, repeated cycles, allowing for continuous feedback and improvements. Incremental, the software is built in smaller, functional pieces that are added to the overall system over time. Benefits: these models enable more flexibility, faster delivery, and better alignment with changing requirements. Next, spiral model risk analysis identify potential risk and mitigations, prototype build and test a working model, evaluate, access the prototype and get feedback. Agile methodologies, iterative approach. Agile embraces rapid iterative development with frequent feedback and adaptation. Collaboration, Agile promotes close collaborations between cross-functional teams and stakeholders. Flexibility, Agile allows for changing and adjustments throughout the development process. Next, continuous delivery. Agile aims to carry working software incrementally and frequently. Scrum framework sprints time boxed iterations that carry incremental working software. Roles: product owner, scrum master, and development team. Artifacts: product backlog, sprint backlog, and increment. Ceremonies: painting, daily stand up, review, and retrospective. Next, extreme programming, pair programming, two developers collaborating on the same code. Next, test driven development, writing test before implementing the code. Next, continuous integration, merging code changes frequently to detect issues early. Next, refactoring, improving the code structure without changing its functionality. Lean software development. First, eliminate waste. Focus on delivering value and remove unnecessary activities. Next, amplify learning. Continuously gather feedback and adapt the development process. Next, decide as late as possible. Delay decision until the last responsible preserve options. Next, we will see continuous integration and deployment. Commit. Developers regularly merge their code changes into a shared repository. Next, build. Automated build process compile and package the software. Next, test. Automated test are run to verify the software functionality and quality. Next, deploy. The software is automatically deployed to the production environment. Continuous integration and deployment automate to build, test, and deployment process, enabling faster and more reliable software delivery. Now let's see the components of process models in software engineering. First, life cycle phases, requirement analysis, gathering and analyzing requirements from stakeholders, design, defining the architecture, components, interfaces, and data, implementation, writing the code according to the design, testing, verifying that the software meets the requirements and is free of defects. Next, Process activities, planning, defining objectives, resource, timelines and responsibilities. Risk management, identifying, analyzing and mitigation risk. Quality assurance, ensuring process and outputs meet quality standards. Next, roles and responsibilities. Stakeholders, groups with interest in the project. Project manager, the project and ensure objectives are met. Developers, write and maintain the code. Let's see the advantages and disadvantages of process models. First, waterfalls model. Advantages: simple and easy to understand, clear structure with defined stages and milestones. Well suited for small projects, works well when requirements are well understood and unlikely to change. Documentation driven. Documentation is proceeded, which helps in understanding and maintaining the system. Easy to manage, sequential approach makes progress measurable and project management. Let's see the disadvantages. Inflexible to changes. Changes are costly and difficult to implement after the project has progressed beyond the initial stages. Late testing. Testing occurs late in the life cycle, increasing the risk of significant issues at a late stage. Poor risk management. Risks are often identified late due to lack of iterative feedback. Iterative model. Advantages: incremental development allows for partial incrementation of the system and iterative improvement. Early feedback. Early iterations provide a basis for feedback and refinement. Risk management. Early iterations help identify and mitigate risk. Adaptable to changes, can accommodate changes based on user feedback and evolving requirements. Disadvantages: requires effective planning, needs careful planning to manage iterations and integrations. Complexity in integration. Each iteration must be properly integrated with the overall system, which can be complex. Possibility of incomplete versions. Early iterations may deliver incomplete features, potentially confusing stakeholders. Conclusion: variety of models. Software development models range from waterfalls to iterative and agile approaches. Flexibility and adaptation. Agile and lean methodologies embraces flexibility, collaboration, and continuous improvement. Continuous learning. Understanding and applying the right process models can help teams deliver better software faster. Thank you for watching this video.